Welcome to Jedi Lessons Week 7B. Today we are talking about fluids. In our problem today, we are working with three different cups, volumes of water. Cups, volumes, however we want to decide what they are. Three different bodies of water, all at the same level. So all of our water is at the same level. Could honestly just use blue for water. That would be smart. Blue. We have water in here, water in here, water in here, all at the same height within each respective container. Our question is, the drawing shows the three containers filled to the same height with the same fluid. In which container, if any, is the pressure at the bottom the greatest? So we are looking for the pressure at the bottom of each of these three containers. We have some variables and units to calculate what the pressure is and determine which one has the greatest. So for the first one, total pressure at the bottom of the container, the SI units are in pascals, which is PA. We're also using atmospheric pressure acting on the opening of the surface. So PA we're going to do for atmospheric. We're working with density, so I'm just going to do D for density. We're also working with gravity, and gravity is equal to acceleration, and we've known this from early on, but gravity and acceleration, 9.8 meters per second squared. We are also working with the height and the depth of our water. That's in meters. If we end up finding it, we find it. If not, we don't. Pressure that is exerted by an incomprehensible fluid at any given depth depends strictly on three factors. So, pressure is based off three factors. So our atmospheric pressure as well, based off of our density. So our atmospheric pressure plus our density times gravity times height. Now that we are looking at our three containers, notice how it doesn't say volume of the water or how many milliliters of water we have. We are just working with density, gravity, and height. Our density is equal amongst all three. So, and we don't have the exact number of that. So I'm just going to do C1 equals C2 equals C3. All three of them have the same density. They all have the same height. So C1 equals C2 equals C3. We don't know what the pressure is either of the water yet, because that's what we're trying to figure out. They all have an open top. Atmospheric pressure is going to be the same because they're all in the same atmosphere. So if we notice that we're not talking about volume, we're not talking about the milliliters of water that we have in here, we're just talking about the density of the liquid. Sure, it may be water, it may not be. We're just talking about the density, the gravity, which is the same amongst all three of these, and the height of the water. They're all at the same height. So if all of these are the same, gravity is equal amongst all, density is equal amongst all, height is equal to amongst all. That means our C1 container 1 is equal to container 2, which is also equal to container 3, because our atmospheric pressure plus the density, gravity, and height are all the same, then the pressure at all of the containers are the same at the bottom of their individual containers. Thank you.